Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aidiel Ikhwan bin Muhammad Ariff. Today, I'm going to present about design of a grid-connected PV power system for residential application in Argentina. So in this presentation, I will introduce about the design problem, design and result, and discussion and conclusion. For the introduction, a photovoltaic system is made up of one or more solar panel, an inverter, and other mechanical and electrical components that harness solar energy to produce electricity. The design problem is high cost and land availability. So based on the meteorological data, as we can see here, the highest average temperature collected is on January, which is 28.74 degrees Celsius, while the lowest temperature being recorded is on June, which is 12.47 degrees Celsius. June has the lowest temperature because Argentina winter months are June to August. The highest PSH data that has been recorded based on the research is on January, which is 5.94 kilowatt hour per meter square, while the lowest PSH is 3.14 kilowatt hour per meter square, which is on June. According to the data taken, the average PSH for the located is approximately around 4.55 kilowatt per hour meter square, and the total PSH is 1659.16 kilowatt hour per meter square. So for the load profile, the data for the load profile has been taken from the 4 different source input, which is lighting, video appliances, refrigeration, and others. The data for the load profile has been recorded for 24 hours. The highest consumed hour for the load demand is at 22 hours, which is 0.852 kilowatt, while the lowest consumed is on the 5th hour, which is approximately around 0.392 kilowatt. Lighting has contributed the highest load demand for household at the Buenos Aires, Argentina. The total power input or load demand for this household is around 13.188 kilowatt hour. So for the design and result, the design of proper PV system, the component is, the first one is for the PV system, and the second is for the inverter. So in order to calculate the PV system sizing, we use the formula here. So the PV array STC that we get after we calculate is around 4.45 kilowatt, and we round off to 5 kilowatt. The estimation quantity of module need to be used is obtained by the formula number of module PV array STC divided by PSTC, and we get around 20 modules. For the inverter sizing, inverter sizing for this system is determined by the given equation where the K value is depending on the type of technology. The K value is 0.95, and we get the P norm inverter is 4.75 kilowatt. For the series arrangement of panel, the max number of modules in series based on open circuit voltage. And for this value, we get around 27 unit max in series. For the parallel arrangement of panel, we get around 1 string per MPPT. Next, for the optimal arrangement, the selected inverter can support 2 MPPT, and each MPPT has 2 inputs, so the total string one can support is 4 strings. For the rooftop and panel area, the roof area required is 39.0.45 meter per square, which is smaller than the average size of house or building. So this setup is possible. The roof should be able to support the total weight of solar panel, which is 436.8 kilograms. So for the one line diagram, figure show how each of the solar panel being connected, which is other will be connected to the inverter. So based on the figure, we can see one inverter, which is 4 string, and each string have one panel. For the cost analysis, the price of solar panel is RM644.18 per unit, and the price of the inverter is around 6,379. The installation cost is assumed is around 5,000 ringgit, and the capital investment for this solar PV system is around 26,854.49 cents. Based on the ROI, the annual cost saving can be estimated by using the yearly feed, which is the system size is 6 kilowatt, and we get the estimated yearly feed is around 5,185.54. So the ROI that after have been calculated is around 6 years. So for discussion, the methodological data analysis has been performed in Buenos Aires, Argentina, where the average PSH for the location is around 4.55 kilowatt meter square, and the total PSH is around 1,659.16 throughout the year for 2021. To propose a PV system design for residential application, a paper has been researched with data on each household to power input or load demand is around 13.188 kilowatt. For the ROI, as we discussed, we get around less than 6 years. So as conclusion, students were able to record the daily solar irradiation and temperature data on the provided website and then plot the monthly data using Microsoft Excel. Students able to design a rooftop grid-connected photovoltaic system for a residential application. That's all from me. Thank you.